He is serving as General Manager, Regional Remote Sensing Center, ISRO, Bangalore since 2021. Sir has more than 3 decades of work experience in ISRO, especially in applications of space technology for management of natural resources and e-governance, including disaster management in the country. His major achievements are in the area of Earth observation applications, including development of algorithms and applications for utilizing multispectral, hyperspectral, microwave, LIDAR data for studying the dynamics of vegetation, urban and water resources, as well as climate change. As General Manager of the Center, he has spearheaded research activities for development of artificial intelligence and machine learning applications for geointelligence. He is also serving as a member of various committees of both central and state government organizations for promoting space technology in governance. Dr. Hebbar has delivered more than 100 lectures at various academic institutions, including schools and colleges across the state, interfacing with schools, colleges, and universities for promoting space education among students and teaching community. Has more than 3,000 students and 250 faculty members visited the center during the last 5 years of his tenure as the head of RRSSE Bangalore. He has been organizing workshops every year by conducting various events and lectures for updating the knowledge on space technology, especially among high school teachers and lecturers. As part of World Space Week celebration, he facilitated visit of students from various schools and colleges, wherein more than 1,500 government school children and 500 college students have been participating in the event since last 5 years. He has been trained at Israel Aerospace Industries on microwave data processing and analysis. It is a matter of privilege that Dr. Hebbar has received ISRO Team Excellence Award in 2020, and he has guided more than 65 batches of BTech, MTech, and MSc students of various institutes, universities from across the country. Sir has published more than 83 research papers in national and international journals of repute. And he has authored more than 5 book chapters and many project reports. With this very brief introduction, I request Dr. Hebbar sir to take over and deliver his talk on applications of UAV systems for digital agriculture. Now over to you, sir.
Sir, answer, yeah, you are able to see the slides?
Yes, sir. Yes, sir.
No issues, no?
Right, sure.
Yes,
Yeah.
Yes, sir. Yes, oh, fine,
Thank
sir.
you. Thank you, Dr. Ramesh, for introduction. And, I welcome all the participants to learn more about remote sensing applications, because now the ministry is focusing more and more towards digital agriculture. So in fact, the current dispensation at the central government, they are very clear about how to transform agriculture with the technology. So with this background, recently many programs have been started at different locations, at different organizations, including ISRO. Ultimate aim is how farmers can benefit from the technology. So one of this thing is to in-season crop monitoring, as well as how to compensate in terms of crop insurance and other things. So you are able to hear now, sir?
Yes, sir. Clear, sir.
Yeah. Okay. Yeah. So now everybody talks of digital agriculture, digital twins. These are the new concepts and other things are coming, where different technologies can be combined to get a relevant information for management. So that is what how is happening. In fact, from our side also, we have given many proposals we have given to Ministry of Agriculture. So how best we can come out with the digital agriculture. In addition, aware that there are a lot of agri-tech companies are coming, trying to bring new advances in remote sensing, sensor technologies, the A and ML and all those things. So this is how the transformation can come as far as agriculture is concerned. And with the population and other things, we need to improve the agriculture production also. It is not only agriculture production, we also come out with a good infrastructure related to cold storage, this, that, and other things, where we require the distribution of the crop, what type of crop is being cultivated, how much it is cultivated. Of course, there are a lot of things that need to be studied. In fact, even now we don't have a good model where we can predict the economics of the crops as well as the marketing related things. So this is how a digital agriculture, if you are involved, implement in across the country for across some of the important crops, probably that will revolutionize as far as Indian agriculture is concerned. So with this background, I'll start this thing, try to complete in around 45 to 50 minutes. If there are any questions are there, you can ask in between also. There is no issue at all. Or we can take up the questions at the end of the things. And I understand that most of you are from colleges, some PhD students and ours. So this will give a more, there are so much things that can be studied using the UAV systems, as well as you can even using the ground-based systems also. So I'll touch upon all these things: ground, UAV, as well as satellite-based platforms. What are the things that can be done? So as far as remote sensing application is concerned, there are 4 important things that people are concentrating on: the crop management, the water management, the soil management, and the weather information. So there are very less focus is given as far as the livestock management is concerned, but many other countries there is also possibility of trying to come out with the livestock management, especially in terms of the fodder requirement and other things. So how to meet the fodder requirement, that is also one of the important things, the task that can be accomplished using the remote sensing techniques. So when you talk of remote sensing platforms, it can be from ground, and now it is UAV. So it is giving a more, ground is giving a more and more importance as far as the UAVs are concerned. And of course, satellites are there since so many years, almost last 5 decades. We have different type of satellites are there. So that has become very important for agriculture monitoring. It started with geology, but now more and more focus is towards agriculture application as far as satellites are concerned. And when it comes to UAVs, the major advantage is whenever you want, wherever you want, you can take the imaging technologies can be utilized for. So that is the advantage of UAVs, whereas satellites has its own limitations, especially if its repetitivity and other things has limitations. You will not be able to get where you want exactly what time and other things. So some of these limitations can be overcome with the UAV, but it covers a small area of say a few acres or few hectares or few square kilometers in a day. So we need to have what is called as a number of UAVs are required to map or monitoring these crops and other things. And there are several ground-based equipments are available now, which also can be utilized because all these images that is coming from satellite or UAVs can be analyzed using ground-based information. So there is a limited amount of ground information is required to process this satellite or UAV-based images. So there are several cameras that is available, or the imaging techniques that is available with the now currently. It can be RGB, a normal red, green, and blue imaging techniques. The thermal imagers, the hyperspectra, the fluorescence, the multispectral sensor, which has become very common as far as UAV is concerned, is multispectral RGB. So it is being operationally used. Whereas hyperspectral and lidar-based sensors, basically they are all in research. There are several application potential is there, but still they are in the R&D activities. And there are so many other things like X-ray, MRI, and other things are also being done at the ground-based. But when you come to satellite-based, even fluorescence also, there are fluorescence-based satellites are available, sensors are available in some of the satellites. And nowadays, even with the UAV-based fluorescence meters are available. So which can be basically utilized for the research and other things. So one of the important research activities that can be utilized as far as UAV is concerned is phenotypic characterization. So agriculture experts, especially the professors and other things, the faculty and other things. Now phenotyping is becoming one of the very important topic, and lot of physiologists and agronomists they want the phenology or both genetic genotypes as well as phenotyping is becoming very important. So like many large companies, seed companies, and they also utilize nowadays this UV-based systems for monitoring crops. Basically, try to find out the phenotypic as well as genotypic characteristics. So this is becoming very popular. Something like Myco or many of the, you are aware, many of these companies they use ground-based as well as UV-based monitoring systems. So basic application as far as these things are concerned is crop mapping, crop health and yield assessment, damage assessment, detection of trees and species identification, assessment of agroforestry, the above ground biomass carbon sequestration, mapping of soil resources. So all these things are becoming very important as far as agriculture is concerned. But these are all, there are several research and technology development is happening, but all are not integrated at a national level. Many of these things like crop mapping or mapping of soil resources that is being carried out at a national level, but many other things are in the research level which has to be made operational. There are many crop indoor program also is being supported by these ground-based or UV-based platforms, especially the crop growth monitoring, the crop stress detection as well as its severity, the crop phenotyping, the crop plant breeding programs, selection of genotypes and other things, especially its appearance as far as the phenotyping is concerned. So it can be possible that this type of technology can be utilized for plant breeding, and of course the post harvest, especially in terms of quality, grading, and sorting. So recently we have started, of course we have a very good collaboration with many of the ICR related centers, even agriculture universities also. Recently, for example, we started one of the R&D activities. How can you find out using some of these spectroradiometers for this oil, especially the coconut oil. So they mix a lot of other oils like petroleum oil or even palm oil and other things. How to find out the quality and grading and other things. So it has given a very good results actually. So there is a possibility of coming out with the new sensor, new technologies and other things as far as because nowadays now everything the people mix. We don't know which is genuine and which is fake. So now to find out these some of the sensor technologies are also coming out like this. So with this, actually, if you see the remote sensing, when you talk, what we measure is the reflected radiation from the Earth's surface. So different materials on the Earth's surface, something like crops or geology or in water and earth, they reflect in a different quantities. So we measure this reflectance. So there are sensors are there which can measure this, which can be ground based, UV based, or using the satellite based. So if you see the typically agriculture, I mean, these crops, if you see, as you are aware, it observes at 0.4 to 0.7. So the reflectance will be very less. So depending on the crop structure, type of crops and other things, the reflectance is very high between 0.4 to 0.7 to 1.4. So subsequently, we have water absorption bands at 1.4, 1.9 and 2.6 nanometers. So this is how the lot of research has been carried out during the last 5-6 decades, and they try to come out with what is the best specification that is possible. Now, if you see the current trend in the space sector, if you consider whether it is space, when I talk space, it includes UAV also. So spectral, it is a hyperspectral imaging as well as microwave-based technologies. So when you're talking of earlier sensor, we used to have 4 to 5 bands, a blue, green, red, NIR, or MIR, middle infrared bands. So when you combine all these things, we will get what is called as natural color composites or the false color composites. In case of false color composite, what you are seeing in the right side, the red color, that corresponds to green vegetation, because there is very high reflectance that is taking place at NIR bands, which we give a red color. So that's why all vegetation looks red in color. So when you make a combination of green, red, and NIR bands. So this is how the remote sensing specialist, they visualize this images and the land use land covers based on the false color composites. So specifically when you come to vegetation, as I told you earlier, because of the chlorophyll absorption, the water absorption, the cell structure, the reflectance will be different. The right side, what you are seeing, you can see the several crops, C3 as well as C4 crop, how their reflectance pattern changes. So depending on the whether it's the chlorophyll content, the all other biochemical contents and other things, it changes. So this is how the remote sensing, the multispectral data, the hyperspectral data enable us try to find out discriminate different type of crops, especially for a crop mapping. When I say crop mapping, at national level crop map, something like whether it is a maize or sunflower or whatever, it is facilitates such type of things. So in addition to this, the bands, whatever I was talking, we can also generate several vegetation indices, something like what is called as normalized different vegetation index, which is reflectance in NIR minus red divided by reflectance in NIR plus red. So this is one of the important vegetation index. It has been evaluated by several thousands of authors for its potential as far as agriculture is concerned. So if you see some of the what we call advanced sensors like MODIS and other things, which can also provide, in addition to the what you call this mapping and other thing, it can also gives some of the important crop parameters like parameters like this leaf area index, the biomass, then fraction of photosynthetically absorbed radiation. So these are things also possible to estimate using the satellite or UAV based platforms. So in this context, the NDVI is being extensively used for agricultural drought assessment, the crop monitoring, condition assessment, and currently is also being used for yield assessment also. As I told you earlier, the hyperspectral camera, which is having hundreds of bands, in addition, like unlike a multispectral camera, which is having 4 to 5 bands, the hyperspectral camera will have hundreds of bands, and it's a continuous bands. So we can generate many indices, which is particular to the some of the important parameters of the crop, whether it can be moisture, whether it can be water content, whether it can be some type of nutritions or the plant growth, something like that. So you have several indices are generated, and its utility as far as agriculture is concerned being very extensively being studied. So as well, what happens is as the crop progresses, there will be shift in reflectance peak. It is shifted towards the NIR bands. So this is called as the red edge. So generally, the physiologists have a lot of significant, give a lot of importance as far as the red edge is concerned, how movement takes place, and which is the important band in the red edge. This thing that is being studied very extensively by many of these physiologists and agronomists. They are studying this. Based on that, there are several indices also have come, the red edge normal difference index, the modified red edge simplicity index. So these are all the important indices. They give the dynamics of the crops in a given day or throughout the cropping season. So with this background, there are, as I told you earlier, there are different imaging sensors are there, which has significance as far as plant phenotypic parameters are concerned. The RGB camera is there, probably will be able to use the 3D model, the volume, geometry, identification, pest and diseases, the soil mapping, a very large scale at 500 or 100 scale, 1:100 scale. If you want, this is the solution for that. Then you have multispectral cameras are there. Basically, they are utilized for the crop condition assessment, the leaf area index, the crop growth progress. So there are several other applications is possible. In addition, there are several papers also indicate that its utility for soil nutrients also. The hyperspectral cameras basically they are for physiological biochemistry, the nutrition as well as insects and pests, diseases, severity and other things. There is other instrument that is very important, thermal camera, which is being utilized for canopy temperature. As you are all aware that canopy temperature plays a very important role as far as the crop growth is concerned. So this is one of the important thing, canopy temperature. So, but we say little expensive cameras, these thermal camera, hyperspectral are very expensive. Nevertheless, its importance as far as agriculture is concerned is very significant. Then LIDAR, light detection and ranging, basically it is utilized for plant height, the 3D model, canopy architecture, the volume, leaf angle, biomass. Then fluorescence as well as magnetic resonance, basically they are both available in satellite based as well as UAV based technology. But all these things why I'm telling is ultimately these are all leads to generation of some of the important plant or crop parameters, which is important for yield assessment. So there are some, as you're aware, there are several these crop models require crop simulation. What I was telling you, crop simulation model. The crop simulation models requires a lot of inputs. Some of these inputs can be generated using this type of systems. And unlike earlier days, where the agriculture research is concerned, we used to measure practically, we used to measure the leaf area index and other thing. But if you have the instrument, it will be very easy to capture all these plant canopy parameters. So there are advantages, disadvantages. As far as satellite is concerned, there's a very stable platform. In fact, it is very good for a large scale of crop monitoring. Whereas as far as aerial is concerned, of course, it is not being used in Indian context. A very limited extent, it is being used for different purposes. Whereas in case of developed countries, UAV aerial is becoming a very important tool as far as the crop monitoring is concerned. Whereas now in India, it is a UAV. It is becoming very, very popular as far as agriculture is concerned. I think most of you are aware that Karnataka government is spending crores of rupees, including even the central government also, trying to map this what you call cadastral maps, coming out with the updated cadastral maps, which become very important as far as the planners and other things are concerned. Of course, ground-based instruments, there are several ground-based instruments are coming up now, which is very essential for agriculture research. So with this, I can say that synergetic use of ground, UAV and satellite-based information is very essential for near real-time monitoring of agriculture. So application of agriculture, application of remote sensing per se, I can say the UAV, which is very farm management. When you're having a very large farms, especially in case of say Punjab, Haryana, other places, even in southern part of country, also very large amount of horticulture plantations and other things is there. So monitoring will become very difficult using the traditional surveying technology. So that is where either remote sensing, either from aerial or UAV or satellite-based platforms comes into a picture. Either it is in terms of pre-planting when you are talking in terms of terrain mapping, soil mapping, or even the weed detection becomes very critical. So early season, whether crop establishment, crop growth, in the mid-season, always in
I think we lost the connection.
what you call modeling techniques. Hello?
Yes, sir. Yes, sir. Now what? It got disconnected, sir. Now
Modeling
fine.
tech. Hello?
It got disconnected, sir. Now fine, sir. Continue, sir. Please. Thank you.
Okay. Look, sometimes there will be small disconnection will be there because of internet and other things. I'm sorry for that. So nowadays, the ministry is insisting that they want multiple forecasts in terms of both yield as well as area. So in that context, we need to integrate various technologies. It is not only the remote sensing technology, even the field-based monitoring and other things also becomes very important. Some of these things I will show in my subsequent slides. So imaging techniques as far as I am highlighting this because many of you are from agriculture background with doing a lot of research and other things. So crop phenotyping is becoming very important. In fact, we have carried out some work with the University of Agriculture Sciences, whether we can retrieve some of the parameters and other things, whether in terms of genotype or phenotyping. So this is imaging technique is becoming very popular now, where they use different sensors, either it is RGB or even the laser techniques, to try to find out some of the phenotypic traits, some morphological, physiological, biochemical performance traits and other things. Especially what we are talking here is the crop growth. Since we have a monitoring capabilities, whether we can find out the crop growth. And subsequently, what is the type of breeding strategy that can be taken up? So this is what is happening nowadays. The phenotyping is automatic phenotyping chambers and other things also have come into the picture now. So I think this is established in many of the agriculture universities as well as this CREDA and other places also. And as far as we are now, you are aware the advanced data analytics AML models in agriculture, it is becoming very popular now. And if you see the international, if you see the most investigated techniques in terms of deep learning, or it is the traditional machine learning techniques. So there are several techniques is being possible, especially for yield prediction, the disease detection, weed detection. There are several other possibilities that are there. And wherein both CNN and ANN, the convolutional neural networks as well as artificial neural networks have become very, it is being utilized very significantly in these research areas. And as far as the crop is concerned, it is the food crops like maize, wheat, rice. It is being investigated heavily. It is being investigated, and to great extent barley, potato, cotton, and other crops also, where basically in terms of yield prediction, the disease detection as well as the crop recognition. And in fact, USA and China is leading as far as AI and ML application is concerned, but India is not far behind. So this is one of the very important aspect I can say, where India also is picking up how best the AI and ML techniques can utilize that. In fact, the sensor technologies, the artificial intelligence, the robotics, all these things are being utilized in a very efficient way in Indian agriculture. So this is one of the how the flow chart shows the AML techniques for processing and analysis of RGB images. When I talk RGB images, it can be from the normal photographs from the cameras, either from normal cameras or from the mobile, or it is from the unmanned aerial vehicles. So lot of studies has been studies has been carried out for apple, pear, peach. Basically, there are the food crops, both in terms of detection as well as the prediction. So the methodology involves image acquisition, image enhancement, image segmentation, feature extraction, and development of AI models. In fact, this is where we are working very strongly in interfacing with both Indian Institute of Horticulture Research as well as Indian agriculture universities. So it is in terms of both detection, prediction, disease, and maturity, especially to provide information related to fruit detection, the yield estimation, as well as can you develop a good disease forecasting models also. These are the type of things that is going on. So as far as the remote sensing data analytics are concerned, initially we used to depend on visual interpretation, but now it is the artificial intelligence era, where it is being utilized very heavily for understanding the different patterns and other things as far as images are concerned, and how it can be utilized for crop mapping, the growth parameters and retrieval of growth parameters and other things. So this is one of the simple example. What I'm trying to tell is from the normal mobile images, they have developed what is called as the fruit detection and counting. So this is very important. As we are fully aware, currently the crop cutting experiment is being done for yield estimation. So whether we can replace this with the technology, when you're talking about replacement with the technology, the ground-based information, or whether it is using satellite or UAV-based technology, it can be replacing this. That is what this either state or central government is thinking, how to reduce the load on manual survey and try to come out with the automation. So this is one of the example I can tell where people have utilized normal camera images from mobile for tomato as well as mango, citrus, such type of crops, how to generate the yield at different levels. Similarly, the terrestrial lidar, it is also becoming very important as far as agriculture is concerned. Both terrestrial lidar as well as UAV based lidar becoming very important. They're becoming advanced technology being utilized. In one of the study, they have studied whether we can identify and detect panicles in case of sorghum. So we also have the terrestrial lidar is there. We are also working with the University of Agriculture Science, trying to find out how best we can come out with some of the models for crop yield modeling. So this is phenotypic facility that is available at US Bangalore Physiology Department. We try to understand whether multispectral or RGB images can be utilized for phenotypic characteristics. So this is basically the NDVI image, what I told earlier, normalized different vegetation indices, whether we can use the crop condition. You can see the potted plants, how can you find out the different type of conditions in terms of whether it is good, medium, or low. So this is the information that can be generated using the UAV images, basically the multispectral data. So we also try to find out whether we can retrieve some of the parameters of leaf area. So leaf area and leaf area index becomes very important, and it has got a very good indication that it is possible to generate the leaf area using this UAV data. So in case of groundnut, you can see the R square is almost as high as 0.85, whereas in case of rice, it is very low. Still, we need to do more work is required to be carried out. So we try to compare the relationships in terms of vegetation index, some of the canopy parameters. There are different vegetation indexes that can be generated, which I told you earlier. So this is normalized difference vegetation index, or the simple ratio index, or the red edge dynamics, which can be studied, and it has given a very good indication that there are significant relationships between these vegetation indices as well biomass and the leaf area index. So similarly, we also try to study the hyperspectral response of mango plantations, especially the mango leaves, at different stages, phenological stages, November, January, March, and May. Try to come out with some of the indices as well as combination of indices to retrieve some of the parameters like chlorophyll, the carotenoid, nitrogen. It has given us some of these things the relationships are very good. Like chlorophyll A, it has given R square of 0.88. But there are some of the other things which is very low, but we need to do some systematic research is required in this case. Whereas soil nutrients are concerned, the relationships are not so good. In fact, NBS is also trying to come out with some of these hyperspectral based parameters for nutrient estimations. So they are also telling that it is still in a research phase only. So the disease detection is becoming very important nowadays, and detection at the early stage is more critical. So if it is advanced stage, it is of no use. So this is one of the study we have carried out in association with the Department of, the University of Agriculture Sciences, wherein the mobile captured images are being utilized, and they are classed group into 4 categories without infection: 1 to 25%, 26 to 50, 51 to 75, and 76 to 100%. So this is depending on the infection levels, disease infection levels. So then we have developed the AI-based model. Basically, here it is a unit model. The model that has been developed for both image processing as well as detection of disease, and based on the severity level, it will tell whether it is in which severity level, whether it is in 1, 2, or 3. So there are some questions which I will try to answer at the lastly. So we are able to achieve something like 80%. But one of the limitations I can say, it is not limitation, but the challenge is all these AML models require a lot of training samples. For example, a simple model like the disease detection model for some of this, it requires at least 50 to 60,000 samples. So the collection of samples and other things is becoming a very difficult task. So this is where still in the AML models are become not so versatile models have not been developed in the Indian context. So we need to do more and more focused research is required. Similarly, we have also established many flux towers across the country, basically trying to find out the carbon dioxide as well as water vapor fluxes in a large what you call agricultural systems. So which covers something like 20 to 30 square kilometers. So here we can find out the fluxes. Based on that, we can characterize the water requirement. It is not only water requirement, we can also find out the productivity and all. There's a possibility there. So there are a lot of sensors are there. If anybody is interested, they can approach us, because since we have already established around 7 to 8 flux towers has been established across the country. This is very expensive. It costs around 70 to 80 lakhs it costs. So under different projects we have established, probably this is one of the things which university can think of establish some these flux towers for Eddie Korean's flux towers for monitoring of carbon dioxide at ecosystem level. Basically, we are doing at ecosystem level, but it can be done at individual crop level also can be done. So now I'll come to some of the important work what you have carried out using the UAV data. Here you can see a comparison of satellite data as well as UAV data. When you are talking of UAV at multispectral, it comes around 5 to 10, 15 centimeters, whereas satellite data, the maximum what you can achieve as of now, it is concerned is 25 centimeters. So you can compare the 25 centimeters. Suppose if you want to retrieve some of these parameters and other things, you require a very high resolution data is required of say 10 to 15 centimeter data will be required. Where you can see here, it is in this case, it is a coconut trees. Individual coconut trees can be seen very clearly. And it's a soil also. You can see that you can also characterize the soil is a very large scales. Also, when you are having a multispectral data, you can also find out the different type of plantation crops, its a density, its a leaf area index, and other things can be characterized very easily. So it will help in improved farm management. So this is the picture what you are showing is from Institute of Horticulture Research at Bangalore. There are several different horticulture plantations are there. So our idea is whether we can discriminate different horticulture plantations, whether we can retrieve some of the canopy parameters and other things. So we are, to a great extent, we are able succeeded in that. You can see here we are able to count the trees using the AML model. I am not going to give details of the AML model now. The DL models and other things, maybe it will be difficult for you to understand at this juncture. So if anybody is interested, please approach me, approach our center, or you can also approach ISRO or any other centers. They will be able to help you in that doing. So in this case, we are able to find out the tree height as well as the projected canopy area. So this is important for as far as the crop management is concerned. And there is also possibility to identify different at a species level also. So with the limited training samples, we are able to identify around four plantations. We are able to identify with a confidence of more than 85%. But many other plantations we are unable to identify because lack of training samples. So in this case, you can see here the different what you call trainings. We have generated the training samples. This is one of the very difficult tasks to do it. So it shows the tree height as well as tree area in the different the ranges 0 to 5, 5 to 10, 10 to 15 meter height. So it is possible to estimate both tree area as well as the tree height possible to estimate. So this is one of the examples which is facing. I am seeing is the experimental research station at IHR. So wherein we are trying to find out the individual mango trees and its extent. And here one of our important thing is whether we can study as far as mango is concerned, whether flowering, the extent of flowering is possible. Because what happens is in case of mango and many of these plantation crops, flowering drop, that is most important. To certain extent, yes, we will be able to do it, but because of the various parameters in terms of the tilt angle and other things, I don't think it is possible to get a 100% flowering, because the flowering also occurs in the bottom part of the top canopies also. So in that context, it may not be possible to find out the actual fruit flowering, but possibly you can extrapolate from the top canopy. Will be able to extrapolate using some simulation models and other things. So that's what we are trying to do. So similarly, this is one of the research station at Institute of Agriculture Sciences Research Station, where we are trying to find the density. So they have a different densities of cashew and mango. We are trying to find out how best you can utilize the UAV based technology of trying to find out the density. So this density makes very important as far as mango yield is concerned. So our ultimate aim is to derive the yields. So there is no practical model that is available as far as the plantation crops are concerned, but still it is in the development stages. Here you can see very clearly, you can see the density, the low density to medium and high density planting. This is as far as the cashew is concerned. So this is one of the example which shows the new flesh coming in the mango, different mango varieties. We also collected some ground information as far as this area is concerned. And now we are trying to classify. Recently, we have acquired. This is acquired only in the February month. We have acquired these data sets. Still, the different modeling and other things are going on as far as the analysis of these programs are concerned. So this again the canopy height map for is our IHR site based on the UAV images. Basically, the RGB. When you're taking of RGB, you can also generate what is called as the DEM and DTM. So digital elevation models as well as digital terrain models. So when you subtract one digital terrain from digital surface model, what you get is the height. So this height represents height of anything, any objects above the surface. So in this case, what we are trying to find out is the height of the canopies. So we are able to very accurately, we are able to do it. I will show you the subsequent slides. I will show you the accuracy of this height estimation is very close. We also measured almost 100 to 2, around 100, 150 samples has been measured in the from the ground just with compared with the height that is estimated from the UAV, and it is very close, and our R square is almost 0.9. So which very clearly shows that some of the canopy parameters like plant height, the leaf area, and the canopy area and other things can be easily estimated using the UAV data. Similarly, we also did some work for field crops like maize and other things. In this case, it is a crop phenology and some of the parameters that can be estimated. As I told you earlier, we are having a collaboration with the many centers. In this case, it is Haryana, one of the ICR centers at Haryana. We try to find out whether we can use the crop classification of different corn. In this case, it is a corn at different phenological stages can you classify at 15 days to till its maturity. So maize crop health assessment using some of these indices, what I told you earlier, especially the normalized different vegetation indices, and the field wise, it is possible to find out the crop health in terms of the indices. Whether high to low, we can see here in this case, it is red to green. Similarly, the fiber crops like jute. So this is the research center at West Bengal, where we are trying to find out what are the parameters that can be retrieved as far as the jute, mesta, and other some of these fiber crops are concerned. So this also is very important. This fiber crops also is as important as far as the ministry is concerned. We are also having a national project as far as jute mapping and its yield assessments are concerned. So now we are trying to find out whether some of these parameters can be estimated using the UAV data. So here you can see the height, the jute height of the what you call these fiber crops, as well as some of the parameters, something like temperature, canopy temperature. What you're trying is canopy temperature and other things which indirectly give the crop growth. Similarly, there is also potential is try to find out the evapotranspiration. And yes, you are all of you are aware, evapotranspiration is one of the very important parameter as far as these crops are concerned. As far as the physiologists are concerned, evapotranspiration is directly indicate the crop yield as well as the crop growth also. So this is one of the example as the Agriculture University at Hyderabad, Rajendra Nagar Agriculture University, trying to find out the evapotranspiration. But there are limitations. We cannot find out from diurnal variation. It's very difficult to find out because we have done some work in Nagpur. Nagpur is famous for oranges. Whether we can find out the trees which are infected by some of the diseases. In this case, the ground measurement has been taken with the different hyperspectroradiometers with infected as a non-infected leaves and try to find out whether it is manifested on the UAV data. But one of the limitations as far as UAV is concerned, as far as the disease identification, disease and pest is, the symptoms may not be reflected in the top leaves. It may be on the lower leaves. So in that context, it is not possible. So as you are fully aware, whatever you are seeing is on the remote sensing data is only on the surface, not on the bottom leaves as well as the lower surface of the leaves. If there is any manifestation, is something like a powdery mildew. The powdery mildew which comes on the lower part of the leaves, and then it is not possible to. So there are many limitations are also there as far as the UAV technology is concerned. So other thing what we are trying to find out is as far as the carbon sequestration is concerned. So when you're talking of carbon sequestration, you require a canopy model or a tree model is required. So this is where we are trying to combine the LIDAR as well as the UV images and to come out with a model that is required for the trees. So in this case, what we are trying to find out is whether we can estimate the radius or the diameter of the trunk, so that we can find out what is the total carbon that is sequestered in the plant. So that is what we are trying to. This is as far as example is concerned, Coffee Research Institute at so with this, I would like to tell we have interface with the Ministry of Agriculture. We are carrying out several national level projects are concerned in terms of crop inventory, agriculture drought assessment, mapping of plantations, land use land cover maps, soil map, and land degradation map. In all these things, we are using the different type of satellite data, as well as nowadays we are also integrating the information that is from the ground, and now we are trying to graduate to the UAV data, because in all these things we also have to do the evaluation, testing and evaluation. We may be doing very good crop mapping and other things. Ultimately, what is required the accuracy. To what accuracy we can generate. So recently we have submitted one proposal. For example, banana. Banana is very important crop. The ministry's requirement of ministry is total solutions as far as the crop is concerned. So we have given a long-term project for the Ministry of Agriculture, how best you can utilize ground UAV as well as satellite-based information for monitoring of a banana crop, including crop yield estimation, the pest and diseases, all these things. But there are several information that is required from the ground. So that is where we are trying to collaborate with many organizations. In this case, National Center for Banana is one of the important collaborator as far as we are concerned. So this is one of the important work what we have carried out in collaboration with the food and agriculture organizations. As you are aware, every year India has to report what is our what you call the trees outside the forest. We have to report what is the extent of tree outside the forest. So this is basically, this work is done by the Forest Survey of India. But the problem is they are doing only as far as random sampling approach they are using. But FAO approached us trying to find the tree outside the forest. When you talk of tree outside the forest, which is the horticulture plantation, the commercial plantation, as well as the forest plantations. So these are the three important things outside the forest, which can be within the urban areas or within the agricultural land. So our idea is to find out what is the total amount of these plantations outside the tree, outside the forest. So here we have utilized a very high resolution data of 50 centimeter, and utilized the deep learning technique has been utilized, try to estimate the total tree components that is available in the net zone area. So that is the ultimate aim is that one. And we have taken 6 districts here: Dharwad, Sitapur, Yamunanagar, Bilara, Jorat and Hassan, to find out different type of, see, you can see here, as far as Dharwad and Sitapur is concerned, they are mango dominant, whereas Yamuna is forest plantation dominant, Bilar is prosopis juliflora dominant, Jorat is tea dominant, whereas Hassan, if you see, it is a typical, I can say typical agroforestry system is followed in Hassan, where you have several, almost 30 to 35% of the net area is under plantations. So our idea is to cater to different agroclimatic regions, whether we can develop a model which is suitable for estimation of the tree components. So this is it has been integrated with the land use land cover map, and try to find out within the net zone area what is the component of forest component, plantation components. So this is the idea. So it has been successfully done to the satisfaction of the food and agricultural organizations, and so probably we will be going to extend it to the entire national level using high resolution data, and try to come out with a good scalable model at a national level. In this context, we have carried out several research at ISRO. So one of these things is the deep learning framework for inventory of plantation crops. When you're talking of plantation, there are 7 to 8, around 11 important plantation crops are available in India: fruit crops, plantation, commercial plantations, right from mango to coffee, tea, and rubber, which comes under commercial plantations. We have generated hundreds of thousands of sampling, training samples has been generated, and try to find out what is the, whether we can map all these things. It is not only mapping in terms of the crop proportions, we also whether it is possible to map in terms of the density, age, and other things. So this is how we are trying to develop the AI-based solutions as far as the Ministry of Agriculture is concerned. And in this case, we are able to achieve 83 to 94% accuracy is able to achieve as far as the mapping is concerned. Mapping of these plantations are concerned. The subsequent work is going on in terms of density and age parameters. I think with this, I will stop here. So, of course, there are several challenges and limitations are also there in terms of computing system, in terms of the adequate data. For example, currently we don't have so many satellites are not available, or so many, we will not be able to capture entire India using the drone alone. We need a very good training and testing data sets is required. And there are several pre-processing steps are required as far as the data analytics are concerned. And there are several algorithms are available as far as this AML algorithms are concerned. In fact, every other day or every year you can see the development has taken place so much. So every year we need to change these models as well as the hyperparameters. And in spite of all these developments, there is no single model that is available in Indian context, which can be operationally used for as far as agriculture is concerned, because Indian agriculture is very complex. It is not so easy to characterize. Simple thing I will tell you: when you have started working with agroforestry, we are seeing that there is a multiple and multi-tier cropping systems are available, where banana, coconut, arecanut, they are all are mixed in different proportions. So in that context, it becomes very difficult to do operational models at nationally relevant models. So with this background, I can say that with the synergetic use of satellite data, UAV ground data, along with several other technologies like sensor networks and other things, it is possible to develop the digital agriculture solutions using the data analytics. So thank you very much for patient listening. I hope I'll be able to transfer some of my knowledge to all of you. And if any support and other things are required, I will welcome always. I'm also agriculture background person, as you are fully aware now. So any support is required to do any research and other things, a collaboration are things also possible. And already we have collaboration with the ICAR, many ICAR institution it is, going on. So I'll welcome any collaborative efforts. Thank you very much. Thank you, sir. Giving me opportunity for KSTA. Specifically, I thank KSTA for giving me this opportunity.
Thank you very much, sir, for a very informative and scintillating talk on use of UAVs in the field of agriculture. On behalf of KSTA and all the participants, I may say thank you. In spite of your busy schedule, you could find time to give this wonderful talk. Now, there are few questions my colleague Mr. Umesh will be reading out, sir. Over to you, Umesh.
Yeah.
Sir, there is one question from Tejaswari. What about the crop situation analysis in case of multi-cropping?
Yeah, this I think I have answered at the last. Of course, one of the things what we are trying to understand is using a very high resolution data, whether it can be satellite or from the UAV based platform, trying to come out is what is the proportion of these things, and can we generate some synthetic images with where the signature differ with the monocrop and multi-crop areas. So this is one of the things we are trying to do. But one thing you remember, when the multi-tier cropping systems are there, something like coffee is there, we are unable to identify coffee. It is only a coffee, what you call shade trees we can identify. Based on that only we will be able to do it. The multi-cropping situation, it will be very difficult. So I can tell very clearly, I can tell it is very difficult as of now. I think I hope that will answer her question.
Yes, sir. Thank you, sir.
So as far as the whom to contact and how to apply, already I have given my email ID. You can write to me gmrcsouth@nrsc.gov.in. So you can share my email if anybody is interested. Yeah.
Sir,
Yeah.
there is one more
I think
question.
with this, yeah.
As an individual, how one can contribute in this field of drone technology that can benefit agriculture? One of the participant is asking this. There are many applications they can do, but they want to hear from you, sir.
No, I have not understood. What is that, sir?
As
Hello?
an individual, how the drone technology can benefit agriculture, sir? Apart from
Yeah. Yeah. See, as you are fully aware now, there are several companies are there which provide solution to the as far as agriculture is concerned. As far as the individual farmers are concerned, I don't say there is possibility is there because it's very expensive. But there are other side of the story is as far as spraying is concerned, which I will not talk. But as far as this thing is, for example, recently some of these big companies they also approached us. Ultimately, what is required? They want yield. whether we can monitor yield in season. That is one of the important thing. So nowadays there are many agri-tech companies, they are using UAV data for finding out the crop growth and yield parameter. That is one side of the things. Other side of the story is, for example, Karnataka, they are covering almost 1.54 square kilometers of UAV data. These are all supplied by the private industries, and also they are processing the data, trying to come out with the cadastral mapping. And the other side, there are many agri-tech companies are there. They are providing solutions for forestry. I know many people are there. They are trying to provide a solution. So Ministry of Agriculture, if you go through their site, we can find out what is the potential of what is the requirement as far as they are concerned. Ministry is concerned, and they also invite RFP from private industries. So in that context, we can really work out how best we can utilize UAV. UAV alone cannot give you any solutions, but you have to work UAV along with some other ground-based systems you have to work out.
Thank you very much, sir. Thank you very much, sir.
Sir, thank you very much once again. From KSTA.
Yeah, there is one more question. Sorry, yeah.
Sir?
There is one more question. There is one more chat I saw. Please shed some light on application of SAR UAV application for agriculture. Any two strong potential applications? So basically, yes, SAR data, it is recently is being introduced as far as UAV is concerned. Of course, from satellite data, it is there since the last 4 or 5 decades, it is available. As of now, there is no operational SAR sensor as far as UAV is concerned. I doubt it, because our own scientist from space application, he has developed a SAR sensor. But yes, SAR has a lot of significance as far as agriculture is concerned. So probably I'll not be able to tell everything in this. You can contact the person who has asked this question. You can contact me. I can give the this one. What you call, I can give the justification as far as the SAR data as far as agriculture is concerned.
Thank you very much, sir.
Okay, sir.
Thank you very much.
Thank you very much, sir.
Dr. Chintamani Pai for next talk. Umesh?
Yeah.
Good morning, sir. Can you hear me?
Yes,
Yeah, we
good
can
morning,
hear.
Chintamani.
Good morning. Good morning, everyone.
Now I request to Mr.
Sir, I will leave from this platform.
Dr. Chintamani Pai. What do you, Umesh?
Yes, sir.
Hello, Chintamani.
Hello, sir.
Welcome, Dr. Chintamani Pai, on behalf of KSTA and Manage and all the participants. Welcome to you, Dr. Chintamani. Before starting the session, I would like to give
Sir,
brief.
Ramesh, I am going. Ramesh, I am leaving the platform.
Yes, sir.
Sir,
Thank you, sir. Thank you very much, sir. Sir, we will share your email ID. Now we have with us Dr. Chintamani Pai. Before starting the session, I would like to give a brief introduction about him. Chintamani is a
Hello.
researcher working in the
Am I
domains-
audible, right, sir?
Yes, you are audible.
Yeah.
So before starting this session, I would like to give brief introduction about Dr. Chintamani Pai. He is a researcher working in the domains of photonics and magnetism with special interest in aerospace technologies. Currently, he is an adjunct faculty at the Department of Aeronautical Engineering, KCT, Coimbatore. In 2021, he was selected for NASA Inside CS program to experience the work of interplanetary missions, and later was part of NASA Space Mission Workshop focused on understanding global ocean biology, aerosols, and clouds to developing data products and services. In 2022, he won the special award at MSU Vadodara, held at MSU Vadodara for presenting smart schooling technologies. He won the Best Poster Award in DAE SSTS 2018 conference in the area of terahertz and magnetic nanofluids, carried out in collaboration with the Tata Institute of Fundamental Research Institute, Mumbai. which is collaborated with UMDAEC Mumbai and 9 Technologies University, Singapore. Currently, he has been working in sensor technologies in the aerospace domain, especially for drones and satellite systems. He is looking forward to establishing a skilled manpower development and providing early exposure to students in aerospace and allied sectors. Recently, he contributed to a book chapter titled Prospects of Drone Technology for the Indian Agriculture. In the book, Evolutionizing Farming, sponsored by Rashtriya Utkara Shiksha Abhiyan, Ministry of Human Resource Development, Government of India. The book is also available in the Amazon. With this brief introduction, I welcome you once again, Dr. Chintamani Pai. Over to you, please.
Thank you, sir. Uh, I hope I'm audible to everyone, right?
Yes, audible, please.
Okay, okay. I'll just share my presentation. Uh,
There is some background noise. Just check with
Let me just, yeah, yeah, I'll just check. Yeah, yeah. Okay, I think, yes, actually, I'm sitting in my campus library. So there is a, because sometimes there is a network issue here. So I hope I'm audible now,
yes,
sir.
yes, you are
I'll
audible.
share my presentation again. Yeah. So let me just check. Yeah. Yeah. Is my presentation visible now?
No, not actually. Presentation is not shared, Doctor. You are sharing your screen,
Is
Doctor.
it visible now, sir?
It is
Yeah.
your screen is shared,
Are
but
you
your
able to see
presentation
my?
is not visible.
Yeah.
Yeah,
Yeah. Now you can see my
yeah, now I can
presentation.
see. Now I can see.
Okay. Okay. Perfect.
Can give slideshow. Yes.
So yeah, I'll just make it. Yeah. Okay. So very good morning, everyone, and uh, first of all, it's a great pleasure again to be a part of this all these great institutions, especially KSTA. I thank CEO Dr. Ramesh and all the other dignitaries for inviting me to give this talk. And as my talk in my talk, I'll be talking about the drone risk assessment and safety analysis, but I'll also try to give some overview of drone technology depending upon how time is available. And of course, at the end of the session, we can have question and answers. So first of all, to start with very first slide, it's always a pleasure whether you're offline or online connected with the state of Karnataka, especially the city of Bangalore, which is Silicon Valley of India and the city of all intellectuals, right from Dr. C.V. Raman to Sir Vishweshwaraya, and then where ISC and the story of ISRO began. So I always feel very energetic whenever I'm in Bangalore, especially uh, giving talk on aerospace or drone technology. And as you are seeing on the screen, that Karnataka has been always at the forefront of the aviation, be it aviation policy, aerospace policy, or even the drone policy. And as this article actually states that the government Karnataka cabinet recently cleared the way for the aerospace and defense policy. And because of this policy, it is actually going to contribute a lot in actually the drone technology and the drone segment. And basically to talk about basically to just give me a moment. I think I'm having some. Okay. Yeah. So okay. So coming back to the Ingenuity Mars helicopter mission. Uh, so I always share whenever we talk about drone technology, I always talk about this Ingenuity Mars helicopter because first of all, it's a technology demonstration to test the first powered flight on Mars. And when we talk about any such drone technology mission, which is going for an interplanetary mission, it lands on the Martian surface. You can actually imagine the kind of technological readiness level it actually goes through. Because when we talk about space, any spacecraft or any spacecraft subsystems, they actually have to survive the harsh conditions of temperature and pressure in space. And when we talk about such Ingenuity Mars helicopter, which is kind of automated drone, which is actually being controlled by the rover, and the rover receives the signals from the Earth, it is a marvel of the mankind's technology, which is being proven, and it is as good as the Wright brothers moment, which actually all of you know that how actually the first manned aircraft was tested by the Wright brothers. So coming to the, I'll because uh, I liked talking about this drone, I'll quickly go through the Ingenuity Mars helicopter and what are the brief outcomes of the Ingenuity Mars helicopter mission. So it is first of all the very first aircraft to achieve powered controlled flight on the another planet, and a feat that has been called as a Wright brothers moment. And it is actually 120.8 flying minutes it has covered, and covering around 10.5 miles. And it has actually covered, it has gone up by around like 24 meters up. Let me make it
Please make a
full screen.
presentation in the slide.
Yeah, yeah, yeah. Okay. And coming to the whole aspects of the Ingenuity Mars drone helicopter, you can actually see how the different parts are. It looks from the picture, it looks very small, but if you are actually want to understand its dimensions, here are the typical dimensions. You can see the blade span itself is around something like 4 feet. So you can imagine how huge it is. And it weighs around 1.8 kgs, but it's very huge. And it flight range of up to 300 meters, and it can fly altitude up to like 5 meters. So the whole aspect of this mission is it has paved the way for the future missions, for the interplanetary space missions, where one can actually color samples, take the photographs. And in the previous talks, you all must have learned about how we can actually mount the sensor, different kinds of sensors, and these sensors can actually collect the data from the agriculture field. So it's not the day is not far when maybe I think even India may come to such mission where you have actually a drone flying on a Martian surface sensor, and the whole advantage of having a sensor recording the Martian surfaces, we are having a very high resolution surface data of the Martian minerals. So then it is, people always think why we always think of drone technology as an emerging technology. Did it just emerge now? recently, or where it has got some roots in the past. So then this is the graph we should look at, that not that unmanned aerial vehicle in general. It is not so new technology. It all started somewhere in the 1849. And generally, when I talk about drone technology, I always refer to, because any war condition will always trigger people minds, their innovations, creativity in their minds, that they come up with the new technology. And it was actually in the year 1849 where the explosive balloons were actually used by Austrians in the year 1849 against their enemies. So what they actually did is use a normal air, make it hot, and the hot air is lighter. The balloon will start going up, and as it starts going up, you put the air volume ratio in such a way that you can actually attach a payload which is carrying the explosives. And when the balloon goes up, I mean, I'm sure they must have had some idea that how the balloon flight is going to be. And once the balloon goes up to certain highest altitude, it bursts, and then the explosive will actually land in the enemy territory. And then in 1903, the Wright brothers' first flight happened, and thereon we have seen the exponential growth in the aviation sector. So not that the drones have emerged uh, suddenly after 2000, but there were attempts in World War II time. People did think about unmanned aircraft vehicles. In the picture here, you can see the British Prime Minister actually watching the unmanned aircraft being constructed, and then in the right bottom, you will actually see the Royal Air Force people are actually maintaining an aircraft. Just then, that time, the chemical batteries were not available, so all these unmanned aircrafts were actually fueled by liquid fuel. Going up, this is a modern scenario where you can see a very huge modern fixed wing aircraft, unmanned aircraft being maintained by the Royal Air Force. And the top and in the bottom left, you actually see something like uh, a container or a freight, but this is not actually to carry the goods. But inside that, you have these kinds of cabins where the Air Force crew is actually operating these aircrafts, and all these are mobile units based on wherever the need comes. They actually go to those locations and they actually carry the whole unit actually moves to depending upon where the need comes. So then, uh, is it just that we have to just talk about the military technology for the sovereignty? So the answer is no, because somewhere down the line, it was the father of Indian space program who actually said that we must be second to none in the application of advanced technologies to the real problems of man and society. And in fact, there in the year 2020, there was actually the birth centenary celebrations in which our honorable Prime Minister, honorable President of India, Sri Ramnath Kovindji, actually said, when the whole world was using space for military domination, which I actually showed right from the World War I era, how actually the inventions were triggered by the war scenario. But it was actually the Dr. Vikram Sarabhai who actually thought for India the space technology is suitable platform for the fast track development of the country. And that is where I feel the country like India, having its major backbone as the agricultural sector, can play a great role through drone technology. In fact, last year there was Bharat Drone Shakti event was organized by the jointly organized by Ministry of Defense and Indian Air Force, where you see most of the aircrafts are maybe defense related, the uh, unmanned aircrafts. But you will also see that there is a focus on the agricultural drones and even the logistic drones. Coming to the Coming to give you the brief overview of drone technology, that India wants to become a drone hub by the world by 2030, and what economy we are looking at is around US 23 billion by 2030, and most of this contribution is going to come from the agricultural sector. And I'm sure there are students, professors among the audience, researchers, and lots of people who aim to join startups. They are going to play a vital role to make India Atmanirbhar Bharat in the drone technology, to become a drone hub. So now slightly shifting towards the agricultural aspects and the risk assessment of drones, I'll slightly start shifting. So this is actually a screenshot from the Ministry of Information and Broadcasting, where it says that India will require at least 1 lakh drone pilots by the next year. Of course, it was in 2023, and still I'm sure the number is around 10 to 20% of the requirement. So there is actually a huge opportunity for youngsters, especially science and technology students, and where the eligibility is to become a drone pilot. Anybody having 10th standard background and minimum 18 years of age can become a drone pilot. And imagine if you are an engineer, you are having a master's degree in science, maybe agriculture, geology, physics. It has opened a completely new way for all the youngsters. So it's my advice to all the youngsters who are attending this talk is not just look at the traditional approach in research, but also to look at this upcoming drone technology. And as the information says that the drone sector is going to add around $3 billion to the agricultural sector and benefit 10 crore farmers. And going next, here is actually from the Indian perspective, how the drone technology is going to benefit. So here are the important domains in India which we expect that the drone technology is going to benefit. And at the forefront, what we are having is infrastructure domain, real estate, where lots of drone applications, right from the hardware level to software level, data processing level, are going to emerge. And after that, we see there is the agricultural sector, which is actually dominating. And when we talk about agricultural sector, what we are actually talking about? We are actually talking about the compilation of the plant count, calculation of fair crop, the crop yield, crop supervision, crop maintenance, and I'm sure already all the experts in this event already have given you the lots of background. Going next, so government of India is actually giving lots of, they have come up with lots of schemes, especially the Kisan drones. And under the liberalized drone rules in 2021, the drone policy emerged. And for the agricultural sector, so that it absorbs this emerging technology, there are lots of benefits given to farmers. For example, there are schemes like Swamitva Yojana, and then the Krushi Yojana, basically I think there is scheme launched as I think Don Didi Yojana, which actually trains the uh, ladies farmers. Okay, and then there is actually the farmers. If you're having the official farmer certificate, you actually get a subsidy on drones. So I'm sure most of you who are having agricultural land and having the certificate can actually make use of all these schemes. When we come to agriculture, especially the use of drones in agriculture, so what we are looking at? So our basic aspect is monitoring, surveillance, but going beyond, we are actually looking at crop health analysis also, maybe estimation of nutrition and water levels, detection of pests, diseases, estimation of height, count, acreage, and yield. And it's not just about the crop health analysis or the estimation of the yield, but we are also using the drones for spraying fertilizers and pesticides and going even to the level of soil analysis. So when we are talking about all these aspects related to drones, especially related to agriculture, because this whole workshop is focused on agriculture, of course you can see that all these drones are huge. Okay, I mean, when we talk about information, we give the information on technology, but actually having hands-on about the technology and utilization of technology on field, there is a vast difference, and there are challenges, on field challenges. So what are those challenges? So here in this talk, I'm going to discuss those challenges. Okay, and these challenges are not okay. Of course, there in all this whole workshop, the experts might have discussed the uh, technology aspect and basically the theoretical aspects of how drones are applied in agriculture. But when it comes to actually taking the data, especially from the drone pilot perspective, or suppose if you are having your own startup, or maybe you are carrying, if there are agriculture students present over here, if you are doing your project, I think it comes down to the bottom line, that how you are going to take care of your drone. First of all, your drone is heavy, okay, and drone is going to have lots of sensors. If you're talking about the hyperspectral measurements from drones, how you're going to take care of your drones. Okay, so drone is something like your car. All of you are, most of you must be having maybe four-wheelers or two-wheelers, and the way we take care of our four-wheelers, two-wheelers daily, it is also important that if you are having your drone, which is like your baby, you have to take care of your baby. And when you are utilizing your baby, maybe for certain studies, applications, survey, you have to make sure that your drone is protected no matter what happens. You plan your studies accordingly. So generally, if people are undergoing these special when or soldiers, when they go for the specialized commando training, all of them are taught with a basic survival guide, right? So in the similar context, I would say that when you are utilizing a drone, okay, whether you are having a normal drone for a can take just doing aerial photography or videography, or you are having a specialized heavy drone like agricultural drone, or maybe drone with these specialized equipments, they are always exposed to some kind of risk. And here we are going to look at how to actually think of or estimate these risks, how to actually brainstorm about these risks, and based on these risks, how we actually estimate what kind of hazards are going to take place. And once we actually kind of do create a mind map, okay, of all these possible hazards depending upon the kind of risk present, and then how we should try to mitigate these hazards. So, when we talk about a risk, a safety risk assessment is a fundament of a safe drone operation and an instrument for continuous improvement. Because when we know the risk, it is something like it is a futuristic impact of a hazard. Because knowing the risk, we are going to take action. So whether if the weather is bad, it is up to the drone pilot whether he is going to fly drone or not. If he is flying the drone, okay, what are the possible hazards? And if he is not flying the drone, what are the other possible, maybe the cost scenarios he has to look at? Okay, and that is where there are psychological factors also play a role apart from the hardware level factors and the environmental factors when we talk about the risk assessment of drones. So I'll just take first in a lucid manner about the risk assessment, how to mitigate with them. So when we talk about the risk assessment, so when these occur, where these occur, why these risk occurs, okay, and how are the risks are likely to occur. What is the source of each of these risks? How they are first of all arising, and who is likely to be affected by the risk. Okay. For example, I'm sure most of you must be investing in the stock market or mutual fund. Whenever we see the advertisement, any commercials regarding mutual funds, there is always a caution given. They are subjected to market risk, but still we go for the risk because we know what are going to be the benefits. Okay, and if there are at all losses, okay, we know how to embrace those losses also. So similarly, when we are actually utilizing drone technology, we assess the risk. What are the risks? And knowing the risk, if we go ahead, okay, what are the benefits? But suppose if there are losses, okay, how to mitigate or how to prevent those losses. So that is what this area is all about. And since the drone technology itself is emerging worldwide, uh, maybe it could be in military domain or maybe in agricultural domain, the whole risk assessment scenario mitigation strategies is complete is in is it's such an area that it is real time developing, and there are lots of
You are muted, doctor. You are on mute, doctor. Unmute.
can you hear me now?
Yes. Yes, yes.
Okay, yeah. So
Now presentation is on.
you you could hear till this slide,
Yes, yes,
correct? You
yes,
could hear till this slide.
yes. Till this slide.
So okay, till this slide you could hear, right? So
Yes.
again, I will just like repeat the point. So what I was saying, as most of you might be dealing with the mutual funds, it comes with a precautionary note that okay, they are subjected to market risk. So similarly, when you are utilizing drone technology in your daily lives, it comes with a risk. But knowing the risk, we know that there are benefits, and that is why we are going forward. And these risks, okay, they are factor wise, they are different, maybe time wise they will vary. Okay, and suppose if there are at all losses, we should know how to mitigate with those losses, how to prevent these losses in advance, so that we are actually able to enjoy the fruits of the technology. And in fact, the way right now the international maybe geopolitical scenario, whatever you call it, the drone technology is evolving in real time. Maybe it is for a military technology or for agriculture. In the agricultural domain, the drone technology has to offer a lot, and there are very gray domains which are still not, people haven't thought about, and there is a lot of what I would say opportunity for youngsters, professionals, and policymakers, technologists, and scientists who can actually fill the gaps when we talk about the risk assessment related with the drones and maybe allied technologies related with drones. So knowing that okay, what is a risk, we try to identify it. Okay, what kind of risk it is, and and knowing that, we try to define our activity. Okay, and that activity may or may not lead to an hazard. So hazard can be a situation that possess a level of threat. Okay, whenever suppose we are using drone technology, of course this is, I'm talking in a more generic way, but in principle the hazard can be a situation, knowing the risk, okay, we have taken an action, and it leads to a level of threat, maybe to life, health, property, or the environment. And now what are the approaches, how we go about identifying such risks? It can be a audit. Okay, we do the, if there is, if the, if any bridge is old, okay, we carry out the structural audits, right, in advance, so that we know what are the risks, and if we do not, if we take certain actions or not take certain actions, how it is going to lead to a hazard, and then what is the probability of occurring that kind of hazard. So these are the generic approaches we talk about when we try to identify the risk. Okay, mostly even we talk about the SWOT analysis, right? So for drone pilot operators, they have to understand what are their individual, they should know their individual SWOT analysis, what are their strengths, weaknesses, opportunities, threats of their own qualities, and depending upon the project being offered and the kind of risk involved in that project, they should able to identify the risk involved, because uh, when we talk about the drone operator, there is a human factor involved. So these aspects automatically come into the picture. So when we talk about the UAV hazard, there after identifying the hazard, and we should document it. As this area is emerging, there are no right now the standard documents available in India. So actually, while doing the literature review for this session, I came across actually few documents which were from the European Space Agency and even NASA. So those topics also I'll touch upon. So when we talk about the UAV risk assessment, okay, it is actually the Federal Aviation Authority in US, okay, requires a pre-flight assessment of any drone flight, and so that you have a prior idea about the risk, how if there are risk factors, if the hazards occur, how you actually go about mitigating those hazards. So there are certain protocols which are set up by FAA regarding the UAVs and their operations. So briefly, to classify these procedures, they are divided into four parts. One is safety hazard identification, then the safety risk assessment, the safety risk mitigation, and followed by documentation. Now, to give you a simple example, suppose you are a drone pilot, you are having your agricultural drone, you are providing a service, but it is mandatory that for all drone operators, they should have their personal data logs about their drones. Every time you are carrying a drone, you should have the data logs. You should have the uh, you should carry a book in which you are making the entry, make a soft copy of that, maintain that book, so that it is like knowing your vehicle, how that vehicle is operating in different conditions, and so that you know the prior history of your equipment, and knowing your equipment how it is operating in different conditions. And if in those conditions you are taking you are subjecting it to again, and it is not giving that performance, then that creates an anomaly, and that itself again becomes a log, data log. And then a drone operator has to self reflect on the whole data logs, why that particular anomaly has occurred, and if that anomaly occurs again, what kind of risk it poses, and if right actions are not taken, what kind of hazards are possible. So going next, so what kind of safety hazards might occur if you're operating drone, no matter whether you're a drone pilot or not. It can be high loss of altitude, it can be loss of control, loss of transmission, collision with manned or unmanned aircraft or buildings or power lines, partial failure or loss of navigation systems, severe weather or climatic events, existence of corrosion, maybe pilot is unfamiliar with the area, okay, rotor failure, takeoff and landing incidents as shooting or overrunning. So a drone pilot, it's not just about the responsibility of drone pilot, but the whole team which is working with drone pilot and carrying out that project, it is the responsibility to actually make a complete mind map of all possible safety hazards related with the project, because even from project to project, your these hazards are going to differ. And that is where actually with experience your ability increases to dealing with assessing the risk and coming up with the risk mitigation strategies. So generally, as suggested by the European Space Agency and FAA, typically what is required is a flight operation data analysis. A drone operator should have the data of its flight operations, daily flight operation, even if these are the test flights, you should keep the data. There has to be flight report logs. There has to be maintenance reports. If some component is not working, you have to keep the record of that. If it is going for repair, after coming repair, you are again carrying out the test flight, you have to maintain the flight data. You have to have the safety audits or assessments which are periodic depending upon how frequently you are using the drones. And uh, if at all any anomalies, unexpected anomalies or incidents occurs, okay, even you might feel okay whether I don't think so it should be reported, but when you are dealing with unmanned aircraft, unmanned UAVs, you have to maintain these logs no matter what happens. I'll actually give examples later in this talk, where actually there have been such platforms developed by NASA where they expect your voluntary contribution, maintaining your confidentiality, whatever kind of anomalies you come across while operating your drones. And I feel that such an effort is needed in our country, where there are many enthusiasts, professional students who are working all the time with drones. Maybe some new projects are being thought of. I think we need to create such a system where all these data logs are collected voluntarily, keeping the confidentiality, and these are actually this data should be open to all the researchers and professional to actually analyze the whole UAV anomalies and coming up with the risk management. So coming to the nature of hazards, what kind of hazards do we have? They can be of the physical type or of the temporal type, environmental. They come from the environmental limits. They can be behavioral, because maybe it depends upon person to person. Maybe in some situations your pilot is always calm, so you might prefer that pilot as well. But maybe for some future project that pilot is not available. You are having a pilot who might you feel is slightly aggressive, or maybe he gets agitated very fast. And if there are some challenging situations while performing while carrying out the drone based studies, these human factors also play a role. Networking limits. Okay, you are having you are carrying your telemetry is not proper, or maybe if your drone is connected to the uh, open door Wi-Fi, again there is some problem with the latency link, and maybe there are lots of other devices, wireless devices present, so all those are causing some problems. Then, depending upon the kind of source, whether it is external or internal, you can also have further hazards. When I talk about the external hazards, it is related with the environmental conditions, maybe signal interference like electromagnetic interference, or maybe if there are cyber security aspects related to drones, even those might come. That somebody is trying to hack your drone, and you have lost the control. You don't know who is hacking into your system. There can be obstacles. There can be moving as obstacles as well, and all these kind of external sources, okay, they act like hazard. We have already discussed about like navigational environment, your GPS signals, not all the satellites are available, number of satellites are fluctuating, or maybe you are not working with the dual band GPS antenna, or there is no such RTK system you are having at your end. So even these can they can act like the external source for creating hazard. I have already discussed about the human factors, so I won't get into that. The internal factors. The internal factors are associated with your drone. It can be the mechanical stresses the drone is subjected to. Okay, the body of the drone. It can be the actuators or the motor. Suddenly, the motor has stopped working. How you deal with those? There can be thermal hazard as well if the drone is operating in the extreme environment. For example, the whole last week the whole India actually experienced heat wave. So if there are such extreme temperatures, how do we take care that drone is going to perform in the optimum way what you expect for your project? For example, if the temperatures are very high, your lithium polymer batteries may not be functioning as good as at lower temperatures. So if they are not working up to the expected their expected performance, then how that is going to affect the whole power distribution within your drones. Okay, I mean your electronic sensors, for example, if you're dealing with thermal sensors, thermal imaging, IR imaging will get affected in high temperatures. So you have to make sure that you are able to understand these kinds of hazards in advance, and accordingly you create strategies to mitigate these hazards. Because if you're carrying out like hyperspectral survey using drones, those are very costly, and suddenly you expect that the environment, the temperatures are going to be very high, or there are other environmental factors. You as a manager of the company handling the project along with the drone pilot and maybe with other experts, it is needed that you should identify what are going to be the possible hazards. It's not just about the safety of your drone, but it is also about how good quality you, how you're ensuring that there is going to be a good data collection, a quality data collection. So these factors are like the internal factors, whether your algorithm, there can be algorithmic error, there can be a software or hardware level errors which can always occur. So assess your drone in advance, or drone related other allied procedures, or maybe data collection methods, algorithms, hardwares. It's not just about drone as an standalone equipment, but all the other allied aspects related with drones. You need to have a prior risk assessment. So how do we go about actually quantifying such risks or occurrence of such risks? So there have been approaches people have developed. So I'll just briefly touch upon these approaches. So how frequently you're actually facing these risks? How occasionally? So we talk about, we kind of quantify the likelihood of your risks. Okay, based on if they're occurring frequently, occasionally, remotely, very improbable event, extremely improbable event. Now, having done this, what do you think? What should be the next step? Can anyone answer? So we know the likelihood of the risk, but is it enough that we are just able to look at the likelihood of the risk? Anyone in the audience?
Wish
I'm
participants
audible.
to respond in the chat box.
Okay, okay. So actually, I'm not able to look at the chat box, but maybe if there are questions later, I'll answer. Yeah. So, so if there are safety risk probability we have identified, then we want to know how big or small going to be the hazard, the severity of these. Having knowing the risk, if the hazard occurs, what is going to be the severity of this hazard, these hazards? Okay, I think I have repeated repeated this slide. So once we know about the likelihood, okay, we now go, if that we keep in the left column, now we go about the impact if the hazard occurs. If we are taking the risk, we are taking the action, okay, mitigative action, but hazard occurs. So what kind of hazard it is going to be, whether it is a negligible hazard, marginal, critical, catastrophic. So this is something called as the risk assessment scoring matrix. Not that it was just invented by the UAV, but it actually exists as per the ISO 12100 standard, if you actually look in Google. But these are being actually being applied for the UAV risk scoring metrics. And once you have such risk scoring metrics based on which you try to quantify the data. Now here we are talking it medium, serious, high. Okay, maybe likelihood of the event is frequent. But when you are having your specific drone model, okay, you actually you come up with the kind of risks you every time you face, and then actually you will start updating the scoring metrics every time. It will always get updated, and based on that you will have certain kind of probability distribution available with you. Once you start operating drone frequently with a specific set of models, with the specific set of sensors, that is when you will automatically have an idea about how frequently any anomalies or any any hazards are coming, what is the severity of those hazards, and based on their severity and their frequency will decide whether your system or whatever project you are going carrying out at that instant, whether it is going to be at high risk or at a low risk. So for example, to make it just to give you an example to make it lucid, because this might sound very theoretical. So for example, if your autopilot controller module fails, okay, that is like hazard. So what is the source? Now autopilot controller is inside drone, because it has a every drone has a flight computer, flight chip. Okay, so it is the nature of the source is internal. It is somewhere at the software level, because we are talking about the algorithm. There is some problem with the algorithm. The chip is functioning fine, and the element of course is UAV. But what can be the possible, now that this is a hazard, what are the possible impacts? So it can cause timing errors, it can cause memory corruption, incorrect specifications, incorrect implementation because your timing is not correct. So maybe whatever mission planner software you're using, that is not being used properly, the data is not timestamp data, whatever imagery you have taken, it doesn't have proper timestamps. Okay, maybe the GPS, your GPS lat long is not exactly correlated with the imagery you have taken. Okay, there can be a loss of flight as well, because it loses uh, its synchronous operation. So what kind of risk assessment you have? Now these risk assessment, you know these might be subject dependent, project dependent, okay, the model dependent. Okay, so not necessary that these risk assessment are universal for these kind of hazard. You need to you need to in prior, you need to have an understanding what kind of hazards this is going to pose to you, and accordingly then you will carry out the risk reduction measures, like you go to the fail-safe autopilot, or you manually intervene, or when it is detected, okay, you simply okay, you if you're carrying out maybe the hyperspectral study, you just stop it, because there is an autopilot issue. So if you have just started taking the data for a huge area of land, you have to stop that, because you know that okay, my other sensors are working properly, my autopilot controller is not working. So I need to make sure that it is working properly, and when it is working properly, we'll again go back for the data collection. So depending upon the kind of risks you are hazards you are expecting, okay, there maybe with your drone there, or related with your project, maybe one time you may have 30 hazards possible. Okay, and all these 30 hazards, for example, how they are actually distributed in this scoring matrix, that one has to map. Okay, so you know that okay, maybe I'm dealing with 100 problems, but those 100 problems, I know most of them they lie in the safety risk probability, and the safety risk severity is also very small, so maybe I don't need to worry about. Not that if I just have five kind of hazards, I'm expecting that I don't need to worry. If at all, if I have five kinds of risk hazards I'm expecting, but all of them lie maybe in the red region, then I have to worry about it every time I need to check my system. So you have a general classification acceptance level as like unacceptable events, tolerable events, or acceptable events. So that if events are those kind of anomalies are acceptable, you may okay, it's okay, there is some problem, but we can still carry out with the data collection, so you don't need any actions required. But if they're tolerable, then maybe you need to implement some mitigation strategies, You need to, maybe if the battery is not working properly, you change the battery. Okay, it is tolerable. Okay, you can change the battery pack and then you can again fly your drone. But if at all there is some problem with the propeller itself, okay, the propeller is maybe is broken or the motor is not working, it is unacceptable. Okay, you cannot fly the drone. For example, you're renting hyperspectral imaging system from a third party. Okay, you're putting it on your drone, you're actually subjecting it to a great hazard, because if all the whole machinery falls down because your propeller is not working, but you want that your drone, you should fly your drone, so you are subjecting it to a great risk, which is unacceptable fact, which is unacceptable. So in that case there has to be a strict mitigation, so that you need to stop the operation. So again, this is like it's all about building your own operational risk assessment. There are no, of course, there are some general rules, uh, general criterias, but as you evolve with your own drone model, which you are using, the kind of sensors you are using, the kind of projects you are handling, you will evolve with your own hazard category and what kind of causes uh, it, what kind of causes it has, and accordingly your scoring matrix will always get updated. So this is the most recent FAA criteria for acceptability of safety risk posed by UAVs. So here you can see that the frequent. So when we talk about frequent, probable, remote, extremely remote, previously in my previous slides uh, I talked about frequent, probable. So how even further to quantify that? So FAA has come up with this recent recent data where when what we mean by a frequent likelihood. Okay, so that should be at least like once per week. Once per week I am facing battery issue. Okay, then that will be mapped in this row. And if the battery is causing some issue, what is the severity of risk I am taking? Whether it is minimal risk, minor, major, hazardous, catastrophic, that all will be dependent on utilization of your drone for specific project. So when we say probable, what we mean by probable in terms of time? So it should be like occur at least once in 3 months. When I talk about a remote likelihood, it is like less than 1 in 3 months, or maybe at least once in 3 years, extremely remote. Less than once in 3 years, or at least once per 30 years. Maybe 30 years, we don't know where the drone will survive or not, but these are the typical the timelines the FAA has come up with. And the extremely improbable is like less than even once per 30 years. And of course then accordingly you have to map the severity of your risks. Again, there has been study from the Indian perspective. A study group was created, and this study group actually kind of started mapping the different risk scenarios. What kind of risk scenarios you will have while you are utilizing the drone, and these risk scenarios are associated with what different kinds of domains for the drone utilization. What are, for example, you are flying a drone. Okay, there is a loss of telemetry, it falls down. Okay, so can anyone tell me it will be actually mapped in what kind of risk scenario over here? You are trying to fly your UAV falls down. Okay, maybe on a car or a building. Then let's say it is infrastructural damage. Now that infrastructural damage, whether it is happening in the military domain, is it a government domain, is it in the transportation, you need to understand the different kinds of impact it is going to create. So if it falls maybe in your friend's compound, okay, the severity will not be much. But if you're flying a drone and by mistake if it falls maybe in a military area or the airport, the severity is going to be very high. So if at all there occurs a damage, there occurs a hazard, then which are the actors we are talking about, who are the stakeholders who will take necessary action, legal action, even to basically remove the hazard? Who are the actors involved in it? So this is like creating a bird's eye view, because if India or any country in the world wants to implement the drone technology, which is going to be associated with our lives on daily basis, you need to have a bird's eye view of all possible risk scenarios. For example, the Amazon uh, came up with the announcement in 2013 that they are going to have a nationwide logistic drone service. But again, in 2013, still the in country like US, the infrastructure was not uh, kind of ready to have implementation of the nationwide logistic drone service. Okay, because you need to have the allotted air channels for the drone movement from one location to another location. And if they are actually facing some interference, okay, how you are going to deal with it? You do not want that your drones, as there are multiple drones in your area carrying out the logistic operation, that they actually collide with each other, and after collision they fall on somebody's car or they fall on the person. The person is at a risk. So if at all such situations occur, who are going to be the actors? Not by actors, I mean who are going to take necessary action. If event has occurred, now what to do? How one should go legally about it? Suppose you are a drone operator, your drone gets hacked, it falls on someone. Now knowing that the drone is hacked, okay, but how you will prove it? So what are the agencies involved? So there has to be the cyber security agency dealing with the drone cyber security. There has to be a mechanism created, uh, basically, which carries out the investigation with the drone cyber security. Then suppose you have paid for your drone maybe 10 lakhs, okay, you have lost your drone because it is hacked, it is not your fault. So how you are going to deal with it? So there has to be the insurance agency. The insurance agency must carry out, should have all the reports with with it, so that it knows that okay, it's not your fault, and then you are able to claim your losses. So this bird's eye view has to be created when we are talking about the implementation of UAV technologies in our daily lives. So, for example, how one actually start creating a simple causal models for UAV risk of crash. So, if I'm talking about a UAV crash, what are the different factors like external sources, internal sources associated with it, and these external sources are driven by which factors? Okay, whether it is because of weather, it is a pilot error, what are the probabilities associated with these sub factors? When I'm talking about the external sources, about internal sources, okay, what are the internal sub factors associated with it, so that they all lead to, it leads to crash. So there is one so one can develop a mathematical approach to create these models for risk assessment, occurrence of hazard, and its mitigation. So as you can see here, uh, for every such factor one can actually come up with probabilistic models. And these probabilistic models, of course, they will also update in time, these probability distributions. But if you know that their time variations are not affecting much your distribution, okay, with respect to your drone system and the set of sensors and the kind of projects you are handling, okay, you need to have this kind of frequency distribution available with you. Okay, what kind of risks your drone or your drone based systems are posed to. So this is just one example where what is called in statistics, we call it as a tornado graph, where with respect to your external factors and internal factors, the kind of the occurrence of certain events, how you actually map these probabilities. So before you go for a project, you have actually the complete estimation, probabilistic estimation of what kind of risk you are going to have. Going next, so NASA has been also working on the, because the whole drone segment is evolving worldwide, so we really do not have any idea what kind of threats, what kind of anomalies with so many different kinds of hardwares coming up, softwares coming up, drone components coming up. Suppose, for example, you are dealing with not maybe uh, a drone which is sold by a drone company, but you are actually having your own drone, assembled drone. You are not providing a service as a pilot. Maybe you are carrying out just your research project in your farm. Okay, if you're dealing with just assemble drone and all the components you are assembling, you are going to have more risks when you are operating. And it is important that the drone community should be aware what kind of risk you are always facing when you're operating drones, what kind of hazards they have, and how you go about mitigating them. So there is one effort, such effort done by NASA, called as unmanned aircraft system safety reporting, where all such, they have created a completely report system where you submit, if you're a visual observer, you are a drone pilot, or you're a part of the crew, you can actually submit a form related with your system. Okay, and when you are submitting such form, of course that is kept, the data is kept confidential, because the whole purpose of having this data is to have the better risk scoring metrics, as what we have seen. So for example, there is some proprietary model of drone available in the market. Maybe the company has not come across certain kind of risks, but as an operator you have come across those risks. And if maybe you are not able to carry out troubleshooting, but if there is such forum available, it gets reported. And maybe a researcher working out or dealing with certain models, they have a prior data available to them that in certain condition, certain kind of weather conditions or maybe environmental conditions, the drone face this kind of anomaly, and this is how it was dealt with, which becomes very much useful for all the drone operators worldwide. So as shown on their website, these are the different kinds of reports the forum actually deals with. It talks about, it deals with, you can report the collision in near mid-air or collision with another unmanned aerial vehicle, the equipment issues, lost link, flyaway, uncontrolled descent. It can be the airspace incursions, environmental hazards, miscommunication, even the procedural issues, however experts you are having. Okay, there can be always a procedural issues as well, depending upon the complexities of the projects you are dealing with. There can be always human errors, there can be injuries. All these can actually be reported. Okay, and the data is kept confidential and it is available for the research. Of course, the major accidents and maybe the criminal activities carried out, of course they are not to be reported. Then how much time do I have? uh,
You can take another 10-15 minutes.
10-15 minutes, right? Okay. So what are the factors of,
Cover the entire syllabus that you wanted to convey here in the
I can
presentation.
I can take for 15 more minutes, right, sir?
Fine, fine, no issues.
Okay, okay. uh, so the importance, when we talk about the risk assessment, okay, suppose you are a drone operator, you are having your own mission planner. How you are going to go about risk assessment? So you will have, these are, I'm just discussing the generic points for all of you. So before the drone takes to the skies, the well thought of a flight plan and a comprehensive risk assessment should be in place. As a drone pilot, you should always have that. No matter how good you are at flying particular drone, you should be aware about the territory in which you are flying, what are going to be the typical environmental factors going to play role. First of all, the safety, how you are going to take care of the safety of the drone pilot, the drone crew, and maybe you should have some idea in that area in which you are going to, in which where you are going to carry out your drone based survey or uh, drone based services you are going to offer. What is a typical population density? How many people are there? Okay, because all those people in those that particular area are going to be at a risk if the drone falls. What are going to be legal compliances, if at all? Are you going to take have you taken all required permissions from the local police station, or maybe have you uh, contacted DGCA, or maybe if there is a, have you checked on the digital sky map? Because I think DGCA has created their own software platform to check whether wherever you are going to carry out a drone based survey or offering drone based service, where that area falls into a red zone or not, because the red zones themselves, they are dynamic in nature. If there is a VVIP movement happening in through that area, even if it is previously green zone, it will suddenly become a red zone. Okay, and whether are you aware of that? And if you're not aware of that, there are going to be, there are going to be consequences. So all these aspects one has to take into account. Okay, how, to what extent your mission is going to be successful, if you are looking at maybe capturing certain kind of aerial images, or maybe certain kind of data through some specialized sensors, how you are going to optimize your resources. So depending upon what is a battery life, if your drone battery life is small, you are going to carry extra battery packs. What is going to be flight time based on all the components connected to the battery, and based on your flight trajectory, what kind of data you are storing. Okay, what is the capacity? Is the data is being transmitted in real time, or it is after the post flight? What are the environmental factors I have already touched upon? And what are the components of such comprehensive flight plan? So you need to have a clear objective and purpose based on your project, what you are going to carry out, what you are going to, for what purpose you are going to utilize your drone for. Is it for aerial photography, surveying, mapping, inspections? Your objective and purpose need to have a very good clarity. Location selection, what are the locations you have chosen for your project? Okay, are you, is it a red zone but still it is needed, or is it a government project you are carrying out in a red zone? So maybe you have certain permissions given by the government, but whether that later is available to you, which mentions that you are allowed to operate in the red zone for a government project. Weather assessment, you can always rely on lots of mobile based applications for the weather assessment. There are lots of softwares which give you very good precise local prediction of weather. Airspace evaluation, okay, if in that airspace, if there are any airspace restrictions or any notams are actually uh, given in advance, all that you need to take care of. Of course, the flight path, because if you're using mission planner, you know what kind of area you are going to carry out your survey. You need to have an optimum flight path for your data collection. Apart from that, like battery management, what are the emergency procedures if certain hazards occur? What are the emergency procedures you are going to look at, you are going to carry out? What are the communication protocols you are using for overall coordination among your team? And of course, the risk assessment, we have already seen how we actually go about making the risk scoring matrix. Okay, and what are like your checklist, regulatory compliance, notification and authorization, data collection and analysis. Because if it is like a research based survey, uh, it's not just about collecting the data, it's not just about having a well managed the flight trajectory, but you should also ensure that your data is collected properly. And the post data collection, the analysis also has to should be carried out in expected scientific with an expected scientific approach. And for all these things, you are going to maintain your flight log, no matter you are carrying out uh, test flight, even maybe it is for like 30 seconds. You need to maintain a flight log. And of course we spoke about risk assessment, so I will not go through this slide much. I'll move ahead. And when we talk about the technology and tools for flight planning, okay, what are the different tools available? Are there any open source software, any proprietary software? When we talk about the flight planning apps or weather apps, or any airspace tools which give you information via Twitter, or maybe specialize, you subscribe to certain services, and maybe you can prior carry out a flight simulation also, you know, so that by feeding these kind of data, you can actually carry out the flight simulation prior to actual drone flight. And then talking about of course the high precision GPS, or suppose your GPS is having, for example, in India now that there are Navik receivers are available, and they are showing very precise data they are giving of their signals. Okay, very high precision Navik systems are available. You can use the Navik receivers also for drone. And then coming to the real world scenario, having done all this thing, let us create a real world scenario. Let's say we want to carry out a aerial mapping of agricultural field. Okay, so how we are actually going to go about? Let us create an imaginary scenario. Let's imagine all of us are part of a drone project, all of us are crew. And how do we go about it? So what is your objective? Your objective would be here: we capture aerial photographs of an agricultural field for crop mapping and analysis purpose. You need to have a clear objective why I am carrying out this aerial mapping of agricultural field. Then what are the considerations here? Where is the location? Is it near a mountain area? Is there a river flowing by? Okay, or is it even near airport, where the airspace aspects will come into the picture? The weather, is the weather is extreme, going to be extreme on the days on which you are going to carry out this aerial mapping? Then those days, of course, you need to avoid. Accordingly, you will make use of a local weather service, or maybe you will rely on the data provided by IMD, or maybe there are mobile apps like Windy. If any of you are using, you can utilize those apps. Okay, for example, what kind of hazards? So even you might come across a situation that you have to carry out aerial mapping, but there are high voltage transmission towers in your vicinity carrying high voltage power cables. So how you are going to deal with them? Because sometimes you may not expect that what kind of hazards they pose. Or if suppose the weather goes bad, your drone is not able to carry out the exact flight trajectory, and if it collides with the power cable, there is going to be a major hazard. So all these aspects uh, you need to have a prior understanding. Okay, again, I'll just conclude this slide, not going through everything. I think we have already discussed these things. So this is how, when you are actually carrying out, whether you are a drone pilot or maybe a manager of the project, you need to have an understanding of these parameters of your location, weather, airspace, flight path, battery management, emergency procedures, risk assessment, communication protocols, safety measures, regulatory compliances, and overall conclusion. Okay, how it is going to be, the project going to be. So not that these things are very easy, and not that there are such ready-made available softwares, but there have been such research level projects going on. uh, and I'm here giving overview of the one of the NASA's what is called as ground risk assessment service provider, which actually if you are going to carry out any drone based or UAV based survey, you can actually submit your flight time, maybe all the details such as weight of your drone with the equipments, maybe the drag coefficient, reference area, and the location, waypoints, wind profiles. Okay, if you are having those kind of data, and based on that, it actually creates the trajectory estimation, causality estimation, and accordingly the code output is generated. So I'll give you the examples of that. So this is actually the complete uh, the unmanned aircraft system traffic management, the whole architecture. So there are the three different aspects or the key players. One is the airspace navigation services protocol functions, then the operator functions, and the other stakeholders. So operator functions, you as a drone operator, you are carrying out a survey. What kind of the different stakeholders are present when you are carrying out such survey? So the system which is functional takes care of all these aspects, and accordingly it estimates what are going to be the possible risks. So just to give you briefly how these causality estimation models work. For example, let's say this rectangle is your area in which you are carrying out aerial mapping of your agricultural field. You need to have some estimation how much is going to be the population density in that area going to be at that instant. And then depending upon your uh, drone flight parameters, you will actually estimate the kinematic impact on the ground. So for example, if this is going to be your drone flight, if mapped on the ground, okay, and in this flight path during that time, what is the probability that some person is going to be present in this particular area? So such models, such statistical models can be actually simulated. So I'm going further with slight certain advancement in the what is called as dynamic ground risk model, in which let's say your drone is facing sudden wind, and because of that sudden wind, it is actually deviated from its predefined flight path. Now, what are going to be the impacts of that? So one can actually develop a physical model of the drone trajectory. Okay, so you have actually the data of latitude, longitude, altitude, waypoints, and the wind simulation models, which are then coupled with your drone flight model. And based on that, you can actually estimate if the drone falls down, what is going to be the possible, what are going to be the possible locations where your drone is going to fall. So if I'm able to simulate this maybe 1,000 number of times, maybe 1 lakh times, it is going to give me a distribution, statistical distribution, which will in principle give me what is the most likelihood area where drone is going to fall, if at all, if at all there, if at all hazard occurs. And these working on these kinds of model can actually help in mitigating hazard or even estimating the possible hazard. So because we know, okay, in this particular area where there is going to be a car or maybe somebody staying over there, people are actually walking through that area, so I can know the kind of hazards are going to be there and the severity of those hazards. So for example, let's look at this drone flight path, which is actually uh, designed over basically near seashore, and there is actually, let's say, the fisherman colony. you can see that there are a lot of fishermen boats, and if there are all these dots represent the waypoints, okay, along which the drone is traveling, and depending upon maybe a simple causality estimation model, suppose if we figure out what is the probability that the drone is going to fall, or if at all, if it is falling, what is going to be the severity of a hazard. So these kind of probabilistic graphs can be generated for the drone having its predefined trajectory. So importance of such safety documentation, because once you have simulated such document, it helps you uh, in advance how you are going to deal with these problems. Not necessary that these models which I have shown they are very realistic, but at least this is a step. I mean, you can take it as a maybe if there are some people, if there are some among audience, if there are people working in computer science or programming or simulations, they can actually get into the depths of these models, where you can come up with a near realistic model which gives you a very realistic causality probability along the waypoints. So overall, the UAV safety risk management is very complex process. It is evolving because the drone technology itself is evolving, whether it is hardware, whether it is software, whether sensors. So you have to always deal with identifying the safety hazards, perform the root cause analysis, assessing the safety risk, consequences, how to mitigate them, and review the efficiency in the implemented actions. And not that you have gone through one circle means it is over, because again you might come across some certain hazard, okay, related with the same parameters, but it might be a completely different kind of risk or hazard you are facing. So this whole UAV as safety risk management is a evolving complex process. And uh, of course I am not a drone operator, but as a drone operator, I'm sure that they are actually facing lots of daily challenges. Drone crew, the experts working with the drone operator, how to go about carrying out your survey or maybe a research project, or you're providing a service to a client. So when I'm talking about hazard, naturally there comes the insurance aspect, because if if at all damage happens, how you're going to claim it. So there was actually such report was such work was carried out by a working group which actually looked at from the insurance perspective, and India has already started working on the drone insurance. So when we talk about the drone risk assessment and mitigation strategies, it is also overlapping with the upcoming insurance policies, or how you come up with insurance products related with the drones and the allied services. So I think I'll stop here, and these are all my references, acknowledgements. And if you want me to contact further regarding this topic or any other topic related with aerospace or drones, this is my contact, and I think we can have some questions.
Pai,
Thank you, Dr. Chintamani.
Dr. Pai, thank you very much for a very informative and insightful talk. I'm sure all the participants will be highly benefited by your talk. There may be a few questions which my colleague Mr. Umesh will be reading out. What do you?
Okay. Am I audible? Am I audible?
But your connection also not there now. You are not there. You got disconnected. You got disconnected. Hello. Sorry for the inconvenience. We, due to power interruption and internet disconnection, we lost all the communication. If there are any questions, please raise your virtual hand. Dr. Chintamani Pai will be able to answer your questions.
Sorry for there was some interruption, but I'm here now. So if there are any questions, I'll be happy to answer.
Dr. Chintamani, please share your last contact slide so that it will be easy for them to communicate further in future if
Okay.
they have any queries.
Sure.
Or if they need any support regarding some drone related activities.
Yeah. Is my slide visible now?
Yes, it is visible.
Okay.
Yes, yes.
So if there are any questions, I can answer. I'll try to answer. If I'm not able to, I may take some time and get back to the answers, and I can, maybe you can contact me by mail.
There is one question in the chat box.
Okay.
Any risk regarding camera? Example, if I want to take a shot in Kharif area, in hilly areas, any robust model to early detection of sudden terrain differences, and the drone stays there at that point and give the options to users whether to continue to the path or take a safer deviation based on real-time terrain status assessment. You can check the question in the
Okay.
chat box.
Okay. Okay. So there are two aspects to these things. First of all, whether you are having any digital elevation data model of your terrain, and how prior to your study you are actually having a realistic satellite data, even with respect to altitude, especially when you are dealing with the forest survey. And of course, you need to, specifically speaking, the lidar data. When you are having a lidar data, you are actually having idea about the altitude of the trees present, their heights. Okay. And accordingly you can actually fly your drone, so that your drone is actually, has some threshold height below which it shouldn't come. And as you are carrying out the survey, it is also needed that your drone doesn't go beyond visual line of sight. That is also important aspect while you are carrying out this. So you need to, as a drone operator, it is needed to have a very strategic place from where you are actually operating the drone. Okay, maybe even some test studies are needed. The test flights are needed. Maybe you can always start with a smaller area when you are carrying out the forest mapping. I think that kind of summarize gives what you're looking for. There is something additional I can answer.
Thank you. There is one more question. I request to ask Banda Tejaswari directly to the speaker. Yes, please introduce yourself and ask the question.
Sir, yes, I'm Tejashwari. So I am a GIS and remote sensing expert at Vasan. So we also currently we are taking the drone footsteps. Like currently we are using the very preliminary RGB data sets, DJI mini drone. So the last time the project that we have got is to fly the drone over Arakur Valley. There's some certain area that we have got our project was focused on. So there we have like multi-cropping and the some and the area is like everything is different, and the main issue is it's the terrain differences are very very high. So
Okay.
currently I understand based on the DJI mini drone, it's a smaller version of the drone. We couldn't be able to, but like is there we are also I mean we have the budget has also been set for higher drones now. So I would like to see. I have gone through the details of the drone, but there is no like currently we when we are flying the drone, we'll take the terrain automated terrain. So at that particular point of the terrain, what I observed is uh, there is a sudden, if I'm putting the take the terrain of the ground existing ground level basis, if the drone is taking the flight, and then if there is a sudden change in the height, if there is a valley portion, so I understand we should be taking it like we should be taking it in the pre-field analysis only. But during that field, if we encounter such type of differences in hilly area, I wanted to know how the camera actually takes the readings. Either like currently one of the applications is SAR sensor for detecting such type terrain, like minute terrain differences. So because sometimes what happens is in the terrain differences also, in because it is multi pattern, some trees are very high and there is some small trees. So uh, the drone actually it's very complicated to fly the drone over. Suppose there's a mango plantations, and also there is a, in between there are some small, like there's several differences in the field only.
Right.
So this is what one type of thing that I have observed. And one more thing I wanted to know, like if we are taking terrain differences, uh, then it will not. I think SRTM drone or some high level drone is needed. But uh, sorry, SRTM is like bare, but in in f- in order to fly such type of drones over multi-cropping areas with high differences, so what is the procedure? And also, one more thing, if we are taking the shot in the Kharif area, the camera is getting so much of moisture and all. I understand, but what type of camera specifications that you could suggest, or some other tricks or hacks to save the camera, that apart from delaying the date of the capture, is there any other way to uh, protect the camera also? That's
Uh,
it, sir.
okay, okay. See, when first of all, my one question is, are you a drone pilot? Because
Yes, sir.
you are a drone pilot, right? You are a DGCA
Yes, sir.
certified. You are a DGCA certified drone pilot, right?
No, no, no,
Okay,
no. I'm not
okay,
DGPA
okay. So first
certified.
of
Yeah.
all, I feel when you are carrying out such specialized and complex projects, you need to
Okay.
have a DGCA approved drone pilot with you, first of all, because
Okay.
that pilot having field experience, okay, which is
Okay.
they undergo through for their tests. I think they are very much well versed how to actually segment your areas into different parts, because what I
Okay.
actually see in your project, that the terrain itself is complex. There are certain there are certain areas in which maybe the trees are they are not also in a certain pattern. They are maybe randomly, there is some random
Yes, yes.
nature
Ready,
of,
because the
yeah,
architecture of the cropping is also like designed
right,
like,
right.
yeah, radial
So
way.
maybe you will have to sit with the drone pilot, and the
Okay.
whole area under investigation, you will have to actually segment it based on the complexities, and
Okay.
accordingly you should actually plan your data collection.
Okay, sir.
Okay, I mean, of course, the DJI drones, what you're using, they're lighter. I mean, if you're talking about the high
Yes.
altitude measurements, so that
Mm-hmm.
is why you have
Yes, sir.
to, you have to switch to maybe octocopters or hexacopters, because they provide a very good aerodynamic stability. And especially if you're talking about the SAR measurements, okay, you need to have a very good
Yeah.
aerodynamic stability for mounting the equipment. I don't know how huge how huge, I mean, what is the size and shape of your SAR equipment?
Okay. So, so we are for that, sir. We are collaborating with one university in NISAC. Those people. So those, I mean, that is a research institution again. It's their. I don't know if they are licensed. I didn't ask this question to them. Uh, that is a hexacopter. Till
Okay,
that I know. I don't know about the. I mean, SAR certifications of that, and their, yeah.
right. So
They
I
are
think,
currently using
uh,
that
yeah,
drone for differentiating the farm ponds and also the fields that is being filled with water, like paddy fields. So for that purpose, they are using currently. So we have asked them to collaborate here in this our area. That's it.
right. Especially if you're dealing with synthetic aperture radar, which is actually your signals, and the signal strength will be dependent upon the altitude also from the ground. So in these kind of projects, it is also needed that you need to have a very good quality altimeter.
Okay.
Okay,
Okay,
because
sir.
it is advisable to maintain the altitude, and then you are actually measuring, taking the SAR data, because
Okay.
otherwise there would be the corrections needed for the data.
Okay. Okay, sir. I get it. I
And
would.
it is always best to sit with the DGC approved drone pilot. Maybe you know how to take the data, how that data matters to you, but knowing the complexity of the terrain, and the way the vegetation is, I think there has to be a DGCA approved drone operator working with you.
Okay. Yes, sir. We would take this note on it. And sir, one more thing I would like to know. Currently, uh, we in hilly areas also there are some sort of regions that are marked as red zone. There are different zones where we can fly the drone. So I would like to know where this sort of like boundaries are that we could collect and delineate. I mean, in that particular area we'll definitely not approve. I mean, we will not take any projects in that particular area.
Right.
So
So as I said, uh, if you are working with the official DGC approved drone operator, he will be aware of these protocols. Like there is a DigiSky map by DGCA, which is a digital map. Maybe I will maybe later share, or maybe in the WhatsApp group I will share with Umesh sir, and you can, all of you can have a look at the DigiSky map.
okay.
So it is actually updated on daily basis.
Oh,
Okay, and in which the zones are actually divided into like green zone, yellow zone, red zone. So wherever you are carrying out study, you should always, even if suppose let's say you have a DGC operator with you, but
yeah.
everyone in the crew should be aware of these aspects.
Okay.
Yes, doctor. Yesterday in the first session, this has been shared information, and we have shared the link also.
Okay,
Uh, yes. Eh, I'm so sorry. Today only I got this link shared by one of my colleagues. So I'm because I'm interested. I have like joined today only. So I have not seen anything that was sent by emails. I'm so sorry. I just
Fine,
directly today joined straight away.
fine. It's okay. Thank you. Hope your questions and
Yes, yes. Thank you so much, Chintamani sir. I would
thank
like to
you.
have a future connection with you I
Sure.
mean,
Maybe you can note down my email
yes, sir. Yes, sir.
and you can get in touch.
Yes,
Are
sir.
there any other questions? I think I saw few hands.
if any other questions, please let me know. We'll unmute you. You can speak directly. If there are no questions, we will wind up now for the lunch break. So we'll be rejoining at 2:45. Now I would like to thank Dr. Chintamani Pai on behalf of KSTA and on behalf of managed team and on behalf of all of us for a wonderful presentation on risk assessment of drones. Thank you very much, Dr. Chintamani Pai ji.
Thank you, sir. Thank you, KSTA. It is always a pleasure to be a part of these wonderful programs with the great planning been done by KSTA. And thanks to Dr. Ramesh, and again thanks to all the colleagues. Other experts whose talk I was not able to attend, but I'm sure if there are records, maybe even I can go through later.
Yes, yes, you can find the records. Thank you, Dr. Chintamani ji.
Yeah.
Dr. Bhaskar sir, now we'll leave for the lunch break. At
Thank you all.
2:45, we'll start the session, sir. I request all of you to join by 2:30.
Okay, okay.
Okay, sir. Fine, sir. Thank you, sir. Thank you.